everyone can start. This chapter introduces the activities which will get your thinking started on any question. There is no need to shy away from the mathematical question and no reason to stay at a blank piece of paper feeling hopeless. Driving straight down the first path that appears hoping the brute force will succeed is not a good tactic either. However, there are productive things you can do. Specializing. The best place to begin is to work on a question. Warehouse. In a warehouse, you obtain 20% discount, but you must pay a 15% sales tax. Which would you prefer to have calculated first, discount or tax? How can you get to grips with such a question? To make progress, you must be clear what the question is asking, but this may not fully emerge until you've done some doodling. The best way to start is by trying some specific cases. I hope you spontaneously want to try it with an item priced at, say, $100. Do so now if you have not already. Surprised by the result? Most people are, and it is that surprise which fuels mathematical thinking. Now, will the same things happen for a price of, say, $120? Write down your calculations and your insights. It is the only way to develop your thinking skills. Try it and see. Now, perhaps using the calculator, try other examples. Your aim in doing this is twofold. To get an idea of what the answer to the question might be, and at the same time to develop a sense of why your answer might be correct. Put another way, by doing example you make the question meaningful to yourself, and you may also begin to see an underlying pattern in all the special cases, which will be the clue to resolving the question completely. What might be the underlying pattern in this question? Perhaps you have experience of the questions like this and know what to do. If so, think how you would encourage someone less experienced to tackle it. Then read my suggestions. It is important to work through my discussions because that is where the important points about mathematical thinking will be introduced and illustrated. How does the final price depends on the order of calculating discount and tax? There should be a pattern in the example you have tried. If not, check your calculations. Will this result be true for other prices? If you are not certain, try some more examples. When you are sure, search for an explanation or read further. Try example until you are sure. A lot depends on the form in which you do your calculations. The usual form for doing discount followed by tax is to calculate the discount. On $100, discount is 20. Subtract it from the price. $100 minus $20 equal $80. Calculate the tax. 15% of the $80 is $12. Wait a sec. Add the tax on get the final price. $80 plus $12 equal $92. Try to find other ways of doing the calculation until you hit upon one which reveals why your result is always true. As a suggestion, you want to find a form of calculation which is independent of the initial price. Yes. To do this, try calculating what the percentage of our original price you pay when the discount has been subtracted, and what percentage of the original price you pay when tax has been added. With any luck, you will have found that 1. Subtracting 20% from the price is the same as paying 80% of it. That is, you pay 0.80 times the price. 0.80 times the price. Wow. 2. Adding 15% to your price is the same as paying 115% of it. That is, you pay 1.15 times the price. Wow. Then, for any initial price of the say $100 US, calculating the discount first, you pay 1.15 times bracket 0.80 times $100 US. Tax first, you pay 0.80 times bracket 1.15 times $100. By writing the calculation in this form, you can see that the order of calculation does not matter, because all that is involved is multiplying the original price by two numbers in either order. If the original price is $P, then calculating the discount first, you pay 1.15 times 0.80 times $P. Tax first, you pay 0.80 times 1.15 times $P. And these are always equal. Notice the value of Notice the value of the standing back from the detail of the calculation and looking at its form or shape. The sort of the reflective activity is fundamental to developing your mathematical thinking. Warehouse illustrates several important aspects of the mathematical thinking, two of which I want to draw to your attention. Firstly, there are specific processes which aid mathematical thinking. In this case, the process being emphasized is specializing, which means turning to examples to learn about the question. The example you choose are special in the sense that they are particular instances of a more general situation in the question. Yes. Secondly, being stuck is a natural state of affairs and something can usually be done about it. Here, the something being suggested is specializing. This is a simple technique which everyone can use, and when people find themselves unable to proceed with a question, suggestion like, have you tried an example? And what happened in this particular case? Or what gets them going again? The next question taken from the Banwell, Sanders, and Tata illustrates other form of specializing. Paper strip. Imagine a long thin strip of the paper stretched out in front of you, left to right. Imagine taking the ends in your hands and placing the right hand end on top of the left. Now press the strip flat so that it is folded in half and has a crease. Repeat the whole operation on the new strip 2 more times. How many creases are there? How many creases will there be if the operation is repeated 10 times in total? Try it now. Stuck. Specialize mentally by counting the creases after 2 folds. Perhaps the diagram will steady your mental image. Specialize by trying it on a strip of paper. Try 3 folds and 4 folds. Look for a pattern. What do you want to find? Be clear and precise. Is there something related to the creases that you can count more easily? Check any conjectures on new examples. I am not going to give you a full resolution of this question. If you are stuck, do not be upset. Being stuck is fine as long as you look on it as an opportunity to learn. Perhaps you can return to the question with a renewed vigor as you read the next chapter. Before you set it aside, try up to 5 folds, either mentally with the diagrams or with the real paper. Count the creases and draw up a table of the results. Whereas with a warehouse, specializing means turning to the numerical example to get to the grips with the questions. Specializing for paper strip means turning to the diagram or to pieces of paper and experimenting. It is important to turn to the object which you are confidently able to manipulate. These may be a physical object or mathematical ones such as diagrams, numbers, or algebraic symbols. Specializing alone is unlikely to resolve a question for you, but it does get you started and involved. The question loses its forbidding exterior and becomes less intimidating. Furthermore, the specific cases should help you to get a sense of what the question is really about, enabling you to make an informed guess. Further careful specializing with an eye on the why rather than the what may lead to insight into what is really happening. The next question is on more familiar ground. Palindromes. A number like 12,321 is called a palindrome. So 1, 2, 3, 2, 1. Okay, it's the same. It's a symmetry pattern. Palindromes, because it reads the same backwards as forwards. Yes. A friend of mine claims that all palindromes with 4 digits are exactly divisible by 11. Are they? Wow. Try it now. Stuck? Find some palindromes with 4 digits. Do you believe, my friend? What do you want to show?